Hello, hello, hello. Yesterday we talked about adding and subtracting polynomials. Just combining like terms. We're not doing anything totally different today. Okay, we're working with multiplying a polynomial by a monomial. Right, there are going to be instances in which you'll be asked to find measurements when you're only given, some side lengths, but they include some unknown values or variables. Often, it's easiest when you simplify these expressions. So what do I mean by that? Let's start off with an example. Number 1. Find the area of the city lot shown. All measurements are in feet. All right, it's easy enough to find the area of a rectangular shape. We just know it's length times width. Just like that. So let's plug in what we know. Area is going to equal 3x is our length, and our width is x minus 45. And we're multiplying them as symbolized by my parentheses. But I'll put a little dot in there just for the heck of it. All right, so here we go. If you got to multiply the length times the width, and here we go, if you're not understanding what I'm saying, this portion right here is the width, okay? This portion right here is the length, so it's just L times W. When we multiply these two things, you all should look and say immediately, well, Mr. Dudek, you've got to distribute, okay? That 3x has to be multiplied by everything on the inside of the parentheses. So 3x times both of those things. So the area is going to equal 3x times x, which is 3x times x. Then we have a minus sign, so minus 3x times 45. Okay. So if you will, I'm going to make these two separate pieces. And now we just have to simplify. So area equals 3 times x is just 3x squared minus 3 times 45 is 135 times x. Since I have an x squared value and an x value, those are not like terms, which means I cannot simplify, which means I'm done here except for one thing. Those of you who forgot to label the units would have missed a point or two. Okay, since we're talking about area, this is square feet. This should make sense because, as we talked about last video, polynomials, they're simply representing numbers. And we know that we can multiply numbers, so you can do the same thing using polynomials. Okay? So a little less legitimate situation, a little more practice here. Down at number 2, simplify the product in this situation. Basically, I have 5x times the quantity, negative 3x squared plus 2x. Well, it's pretty simple. Let's distribute. That 5x has to be multiplied by every single thing in there. So we have 5 times x times negative 3 times x squared. That's 5x times our first term. That's all multiplication plus 5x times 2x, or 5 times x times 2 times x. And since this is multiplication, we kind of have two pieces to the puzzle. Everything here is multiplied, everything here is multiplied with an addition sign in the middle. So PEMDAS says let's multiply first. So 5 times negative 3 is negative 15 times, and x times x squared is x cubed, plus, and now let's do the second part. 5 times 2 is 10, and x times x is x squared. Since these are not like terms, this is your final answer. Negative 15x cubed plus 10x squared. Number 3, I'd like you to try on your own. So it might be to your benefit to pause right now and work on that. or you can come back and do it at the end. But I want to see that done tomorrow. That's going to be what we start with. Number 4 is just another example. It's a little bit crazier. So I'd like to give it a shot here. Same type of thing though. Just because you have -9 times a times b times c, doesn't matter that there's 3 variables. This is still one monomial. And then inside our parentheses, we still have 3 different monomials. Or we have a trinomial, if you want to call it that. So we need to distribute. So -9 times -4 is +36. And it kind of combining our like terms here. A times A is A squared. B times B is B squared. And C is on its own. Then we put our plus symbol because there's a plus sign right there. Uh-oh. -9 times +3 is -27. A times, well, there's no other A's, so just one A. B times B means there's 2 B's. And C times C means there's 2 C's. Okay, what's the symbol? It's minus. Okay, -9 times 2 is -18. A, B, C, X, Z, since there's only one of each of those variables. Now let's simplify this a little bit. I know we can. So, question is, first of all, we have 3 terms. There's an a squared, b squared, c in our first term. Does that exact pattern, a squared, b squared, c, belong to either of our other terms? And it does not look like it. If it did, then we'd be able to combine these. But since they do not, we can simply only rewrite them and simplify our addition and subtraction signs. So here's this. Instead of saying plus -27, I'm just going to say minus 27 ab squared c squared. And we have minus and negative, so that means plus 18abcxz. That is as simple as you're going to be able to make it. All right, down to the summary section. Polynomials are expressions that represent numbers. You got to remember that. What that means is that, yes, we can add, subtract, multiply, and divide these different polynomials, just like we can add, subtract, multiply, and divide regular numbers. The key, especially when multiplying, is to know which terms are combined with which terms. And in these cases, so like number 4, you just combine your numbers, you multiply those, and you multiply all the variables that match up. Basically, you're telling me how many A's are in this one. All right, there's 2. There's 2 B's. There's 1 C. Okay, and number 2, just a reminder, please complete number 3 for tomorrow's class.